2.2 number 102, volume of water. Water is flowing into a conical drinking cup with an altitude of 4 inches and a radius of 2 inches as shown in the figure. This is another example of a problem that you will almost certainly see again in calc class. It was on the AP exam 2 years ago. Kind of like the volume of the box problem, kind of like the triangles, the shadow problems. All of these are pre-calculus problems, and you're just setting it up right now, and then in calculus you'll solve to find like the minimum time it takes or how fast something is going. But for right now, the bulk of these problems is actually setting up the functions, which is what we're doing right here. Okay, so it tells us that the height is 4. This is all inches. And the radius is 2 inches. Okay, and then we've got, we've got your height and you've got your r. So we'll call that r and we'll call this h. So you can see that, like, this is a variable. As it's getting filled, the radius is increasing and the height is increasing, but just the cone itself is 2-inch radius, 4-inch height. Again, we have two similar triangles, so think back to our geometry days. If this is h and this is r and this is 4 and this is 2, we can set up a proportion, which is an equation to relate those. So you could say r is to h as 2 is to 4. Okay, since they're similar triangles, that is true. Okay, so let's go, maybe I'm jumping ahead. Let's see what it's actually asking. Write the radius r of the surface of the water as a function of its depth. Okay, so we want to solve for r. We want to write r in terms of h. We're looking for r of h. That means r in catch up video. There we go. Okay, that's what we're looking for. So I'm going to solve for r. So I'm going to cross multiply. 4r equals 2h. Solving for r, I'm going to divide by 4. So I get r equals 1/2 h, which is h over 2, however you prefer it. So that's our answer for A, radius as a function of h. So that's r of h equals 1/2 h. B, write the volume V of the water as a function of its depth. Okay, volume, so this is A. B, so we have a cone, and the volume of the cone is 1/3 area of the base, so pi r squared times the height. So that's the volume of a cone. That volume has two different variables, r and h. We want to write the volume as a function of just h. We don't want r in it. Well, luckily, we just solved for r in terms of h. So we can take that and plug it in for r right there. So now we have V equals 1/3 pi. I'm going to call that pi over 3. R squared, so it's 1/2 h squared times h. And now we just have to clean up our function here. So pi over 3, 1/2 squared is 1/4 h squared times h. So V equals pi over 12 h cubed. Okay, so we're done. Just to kind of clarify what in fact we did, we have two variables right at the beginning, r and h. Sometimes in math it's helpful, even necessary, to eliminate one of the variables. So we write one in terms of the other. R is the same at 1/2 h. If we wanted to, we could have solved for h there, and we would have gotten 2r equals h. We could write h as a function of r, or r as a function of h, is what we did in this problem. Now we can write the volume equation with just one variable. Okay, since we solved r as 1/2 h, you can plug it in. Now our volume is just pi over 12 h cubed.